Okay, so we're still doing book 5.6, Rules of Exponents and Scientific Notation, but now we're on page 5, okay? Scientific notation. So what is scientific notation? It's what we do is when we have really big numbers, we don't want to have to write all those zeros. And so if we look at the distance from the Earth to the Sun in kilometers, that's a really big number. And if I change it to meters, it's even a bigger number. That's a lot of zeros. So there's an easy way to write this simply using scientific notation. And if I look at COVID-19, the virus, here's the virus. If I measure the diameter of the virus, it's 1 nanometer. I mean, I googled that. And if I change that to meters, it's like 0.0000001 of a meter. Okay? 10th, 100,000. Okay, it's very, very small. Okay? So I don't want to write this. I want to write this easily, and we use scientific notation to write it. So we're going to start small. So evaluate. Value just means find the value of something. So if I say, what's the value of that shirt? Maybe it's 100 reals. Okay. So is it big or small? And circle big or small. So 10 squared, well, that's 10 times 10. So that's 100. Okay. 10 to the negative 2. Well, that negative means move them to the other side. So we're going to move them to the other side. Nothing up there is 1. Well, we know 10 squared is 100. So that's 1 over 100. So that's like a cake that's cut into 100 pieces, and my brother and his friends come down and eat everything and leave 1 piece. So it's a very small number. And if we want to write this as a decimal, we use our calculator, and I can put this on my calculator, use this button, okay, with the box, and then I can put negative 2 in there. Oops, let's do it again. 10, and in the box I'm going to put negative 2. And there I can see there's it as a fraction, SD for decimal, and I can see it's 0.01. So 0.01. So it's a very small number, and 100 is a big number. So let's look. 10 to the negative 3. What's that going to be? 10 to the negative 3. 0.001. And 10 to the 3. 10 to the 2 had 2 zeros. So I'm going to guess 10 to the 3 has 3 zeros, because it's 10 times 10 times 10. Let's check. Yep, 3 zeros. 3 zeros. 10 to the 1. That means 10 just once, which is 10. 10 to the negative 1. Let's check. SD, 0.1. Which one's big? The 1 is big, and the negative is small. Here, which one's big? The 3 is big, and the negative is small. So positive exponents make big numbers here, and negative exponents make small numbers, okay, when we have the 10. So here with the 4s, which one is going to make a big number? The 4 or the negative 4? Yeah, the 4 is going to make a big number, and the negative 4 is going to make a small number. 10 to the 4, I'm going to guess it has 4 zeros. Let's check. 10 to the power of 4. Yep, 4 zeros. 10 to the negative 4. I know it's going to be 0.0. So if there's a 4, then there's 3 zeros after the point. So it makes a small number. So negative exponents on the 10 make a small number, and positive exponents make big numbers. We have to remember that. So all of the next questions, I've made it so the answer is going to be 10 squared or 10 to the negative 2 when it goes in here. Okay, so if I have 6.54321 or blah, 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 times something, and it has to get bigger to 600, would I multiply it by 10 squared or 10 to the negative 2? 10 squared is a big number. 10 to the negative 2 is a small number. So would I multiply 6 by a big number to make it bigger, or would I use a small number? Yeah, to make things bigger, I need to multiply it by a big number, which is 10 squared. Here I have 1 point something, and here I have 100. 1 to 100, I need to make it bigger. So to make something bigger, I need to multiply it by a big number. So I'm going to use 10 squared. Here I have 200, and here I have 2. I want to make it smaller. Well, if I want to multiply it by something, I need to multiply it by something small to make it smaller. So I'm going to multiply it by the negative 2, because this is a small number, and so this is going to, when I multiply it, it's going to make it smaller. So here I have 100, and I have 1. I want to make it smaller, so I'm going to multiply it by a big number or a small number to make it smaller. A small number. There we go. Here I have 98, and I have 9,000. That's getting bigger. So to make something bigger, I need the positive exponent. 98 to something less than 0. That's smaller. So to make something smaller, I'm going to have to use the negative exponent. Okay, because this is a small, something small, so when I multiply it by this, it's going to get smaller. 1 to like a lot smaller than 0. So this is getting smaller. So I'm going to use the small exponent. This is 1 to like 100. That gets bigger. So to make something bigger, I need to use 10 squared. A positive exponent. 1,000 to 100,000. This is getting much bigger. So I need to multiply it by the big thing to make something bigger. 1,000 to 12. That got smaller. So I'm going to use the negative exponent. Oops, that's funny. I'm going to use the negative exponent to make something smaller. 65 to like 0. I made it smaller. So if I want to make something smaller, negative exponents. 65 to 6,000. That gets bigger. So I should use the positive exponent. Whoa, this is like 200,000 to 22 million. So this went from, okay, big to really big. So to make something bigger, I'm going to use the positive exponent. So this went from 200,000 to 2,000. So now it went smaller. So now I'm going to use the negative exponent. 9 to like less than 0. So it got really small. To make something smaller, I'm going to use the negative exponent. 9 to like 900. I'm making it bigger. So 10 squared. Okay. So now, vocabulary. So in English we have words and we have letters. The letters make up words. And in math we have numbers and then we have digits. Numbers are made up of digits. So I'm going to use the word digit. Okay. Digit is just like the alphabet, but for numbers. So how do I write things in scientific notation? So this is the rule right here. There must be one digit in front of the decimal point, but it can't be 0. So I take any one of these digits, but not the 0, in front of the decimal point. Okay, so here's my digits. It can't be 0. So if I have just a 3 in front of the decimal point, it's good. If I have a 2 in front of the decimal point, it's good. 12? Not good, because look, there's 2 digits. A 1 and a 2 in front of the decimal point. It's not good. If I put 123 in front, it's not good, because there's 1, 2, 3 digits in front. And so here, if I put a 0 in front, it's a 1 digit, but we can't use 0. It says it can't be 0. So don't put a 0 in front for scientific notation. So you're going to have a number times 10 with some exponent, and it's going to have 1 digit in the front. Okay, so let's look at the rules. how to do it. So it says write 654 point blah 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 in scientific notation. Step 1. Move the decimal point so there's only one digit in front of the decimal point. Okay, so it's here. I'm going to move it, and put the decimal point here. Okay. Now it says, how many spaces did you move the decimal point? 2 spaces. You have to remember that 2. Okay. Then you write times 10 afterward. And we're either going to choose a 2 exponent or a -2, a positive or a -2. +2 make things big, and -2 makes things small. Okay? So we have to go, this times a big or small number is going to equal 654. Because we want to have the same number, we just want to write it in a different form. So it has to be equal to this. So 6, and we want to make it bigger. So we pick the +2. So if I do this times this, it's going to equal that. Let's check on our calculator. 6.54321 times 10. Oops, that's not a 10. 10 to the 2. And look, it's equal to that. So this is the scientific notation. And it's the same thing, but it's just written differently. Let's look at the next example. So now I have a very small number, and it says write this in scientific notation. So I need to move the decimal until there's one digit in front of the decimal point, but the digit can't be 0. So here's one digit, but it's 0, so it's not good. So 1, 2, 3. I'm moving it to here. And I moved it 3 spaces. So then I write this number, put the times 10, and because I moved it 3 spaces, I have to choose, do I put the +3 or -3? So let's check. Here's the number I made. I moved the decimal, and it has to be equal to the original number. So it's 2, but it has to be equal to a very small number. So it was 2, and then it got really small. So would I multiply it by a small number or a big number? Small number, because it's got to get smaller. So I'd have to choose the small one with the -3. So this is the scientific notation, and it's equal to this. And let's check in our calculator. 2.3456 times 10, use that box, -3. See? This, oops, this 234, I wrote the number wrong. I have to fix the book. I cut it off because it was too long. Pretend that's not there. Okay? Because I said, oh, I don't want to write that much. Okay, so you can see this, when I multiply it, okay, it's not equal to that, but it's because I typed it wrong in the book. Okay, so let's do some examples together. Okay? So, it says, write this number in scientific notation, and check your answer with your calculator. So I want to put the decimal, here's my 7, I want to put the decimal here because then I have one digit in front that's not 0. So how many places do I have to move the decimal point? 1, 2, 3, 4. Okay, so I have to move the decimal place 4, so it's going to be 7 point. Okay, when I have all those zeros afterwards, I don't have to write them. And you say, well, why? If someone said, how old are you? And you said, oh, I'm 21.000, they would look at you funny. You would just say, I'm 21. Okay, so when you have zeros after the decimal place, you don't have to write them. Okay, and then you put times 10, and then you have to choose if it's a big number or a small number. So this has to be equal to 70,000. So this is 7, and this is 70,000. It's getting big. Okay, it has to get bigger. So would I choose the +4 or the -4 to make it big? +4. So let's check on our calculator. 7 times 10 to the 4, 70,000. So this is scientific notation. You don't need to write that. That's just to help you choose the correct exponent for the 10. Okay, let's do the next one. Sometimes there's no decimal. So if there's no decimal, you always put the decimal point on the right. Okay? But I want to move this decimal point so there's only one digit in front. So I'd put it here, 4.9. And look at all those zeros. I don't have to write them because they're after the decimal point. And then I go times 10. Oh, I need to move it. I like to move it. 1, 2, 3, 4, 5, 6, 7, 8. So I have to choose 8 or negative 8 for that exponent. And it has to be equal to a very big number. So I have 4, and then I have like 500 million. That's really big. So I want to make this big. So I'm going to choose the positive one, 8. So that's scientific notation. So let me check to see if it's correct. 4.9 times 10, use that to the 8. Yep, it's a very big number. Okay, let's do the next one. So I need to move the decimal here, because then I'll have one digit in front. If someone says, how old are you? And you say, I'm 021, or I'm 0021, it's still 21, but it's a really weird way to say it. You don't put the zeros in the front. So when I move this decimal here, look at all these zeros. How many zeros are there? 1, 2, 3, 4, 5, 6. So if I move the decimal here, look at all those zeros in the front. It's like this saying you're 0021 years old. When they're in the front like this, you can erase them. Now, how many places did we move the decimal? 1, 2, 3, 4, 5, 6 places. So I have to times this by 10, and I have to choose 6 or negative 6. And that has to be equal to a very small number, because that's a small number, right? So I have 4 going to a small number. How do I make something small? Would I choose the big exponent or the small exponent? The small exponent. And let's check. 4.955 times 10 to the negative 6. Yep, that's equal to this. You see? So that is scientific notation. So here I need to put the decimal place here, because then I'll have the 7 in the front. And how many places do I move it? 1, 2, 3, 4. So now I have to decide, is it going to be positive 4 or negative 4 exponent? It has to equal to, that's a very small number. Very small. So I'm going from 7 down to a very small number. So I need to make this really small. So to make something smaller, I'd choose a negative exponent. Let's check on our calculator. 7.51 times 10 to a negative 4. Yep, you can see that this is equal to this. So these are the same numbers, but we just write it differently. Okay, let's look at the next one. Oh, there's no decimal, so I can't move it. It's okay. So if there's no decimal, you always put it on the right. Okay, now I want to move it so there's only one digit in the front. There, this 3 will be in the front, so it's going to go 3.25. Do I need all those zeros? Nope, I don't need all those zeros. Times 10, and how many places did we move it? 1, 2, 3, 4, 5, 6, 7. 7 places. So this is a big number, 32 million. So I'm going from 3 to a very big number. So would I choose positive 7 or negative 7? Yeah, I have to use the positive 7 because that's going to make a big number. So that's my scientific notation, and let's check in our calculator. 3.25 times 10. Yep, this and this are the same thing. Good. Okay, so I need to move this so there's one digit in the front that's not 0. I'd move it here. So I can go 1, 2, So it's going to go 4 point, there's nothing afterwards, so I'll put the decimal there, times 10. How many places do I move it? 1, 2, 3, 4, 5, 6, 7. So, is this a big or a small number? Oh, it's really small. So I need to make this from 4 to a very small number. So would I use a positive exponent here or a negative exponent? I gotta make it smaller. So I'd use a small number here. Negative 7. So let's check. If you wrote it like this with a 4, that's correct. You can put the decimal in or not put the decimal in, or you can put 4.0 like that. Those are all the same thing for the basic rules for scientific notation. So let's check. 4 point times 10 to the power of negative 7. See, I made a very small number. Okay. So I want to put my decimal place here, just between the 5 and the 8, so there's 1 digit in the front, like that. And this is not 0. Okay, so now I have to say, how many places did I move it? The decimal. 1, 2, 3, 4. Now, is this a big or a small number? Small. Okay, so I'm going from 5 to a very, we'll say very small. 5 to a very small number. So would I put 4 here or a negative 4? I've got to make it smaller. So if I'm making something smaller, I'm going to put a negative 4 here. So that's scientific notation. Let's check. 5.89. Pardon me. Yep. See, this is equal to this. Let me have some tea so I don't hurt your ears. Okay, that's better. Oh dear. There's no decimal here. Where is it? If there's no decimal, it's always on the right side here. Okay. So I want to move it so there's 1 digit in the front that's not 0. So here I would have as 2.130. Do I need the 0? Nope. I don't need any zeros at the end. Times 10. How many places do I move it? 1, 2, 3. So now 2,000. Okay, that's kind of a big number. I'm going from 2 to 2,000, a big number. I need to make it bigger. So would I use positive 3 or negative 3? Positive 3, because this is big. 2 times a big number will make it bigger. So let's check on our calculator. 2.13 times 10 to the power of 3. Yep, that's good. All right, so now you guys can finish the rest. Let's go to the next page. Okay. So now it says, write the number as a decimal and check your answers with your calculator. So now this is in scientific notation, so we have to change it to a regular number. So what I do is I take this, I just write it in the middle, okay? Because I don't know if I have to move the decimal left or right. And then I go -5. If I multiply this number by a negative exponent here, this is small, which means it's going to make this even smaller. So it's trying to make this a small number. So here's left and here's right. So to make this number smaller, I have to move the decimal to the left 5 jumps. Now don't think 5 zeros, 5 jumps like an arnab, like a rabbit. 1, 2, 3, 4, 5. And lazim, you must write these little jumps. Just draw the jumps. And wherever there's an empty jump, what should you put there? Yeah, put a 0. Okay, so that's our new number. And we go, well, it looks kind of messy, so we should write it again. Okay, but I have to tell you, old people, young people. Say I have something, a number, say I have 5 million. Old people write 5 million this way. Younger people write 5 million this way. Okay? We group things from the decimal out into groups of 3. We group them the same, but older people put a comma and younger people put a space because quite a few years ago, internationally, the metric system changed, and the metric system says, for Standard International, we say no more commas. We don't put the commas. We just put a very small space. Okay, so when we write these kind of numbers, we start at the decimal and we do groups of 3. Group of 3, so we go 0.1, 2, 3. So see how I did groups of 3 going out from the decimal? Now some people like to put a 0 on the other side, so you can go 0.0000104. You can put a 0 here, or you don't have to put a 0 here. It's up to you. Okay? So now this one, let's write it in the middle. Now it says positive 3. Positive 3, this means big, which means we need to make this number bigger. To make this number bigger, I have to move the decimal to the right. 3 jumps. 1, 2, 3. So I'm going to put the decimal here. So it's 3,141.59. Okay. So you moved the decimal by 3 and you made it bigger. So this one says I have to make the number smaller. So 1.174, and I need to make it smaller. So I'm going to move it 4 jumps to the left. 1, 2, 3, 4. And wherever there's an empty jump, I just put a 0. But to make this nicer, I'm going to start at the decimal and put it in groups of 3. So that should be 0.000 space 117 space 4. And you can put a 0 here if you want. It's up to you. Okay? Ooh, this means positive, which means I have to make this number bigger by 11 jumps. So 2.35. Bigger means I have to move to the right by 11 jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put your decimal. And wherever there's an empty jump, you put a 0. Now starting at the decimal, we cut it into groups of 3. So that's equal to 235. I don't know that number. It's so big. That would be billions. That's millions. What's after billions? Trillions. Ooh, that's a big number. Okay. Oh, 0. 0 is not positive, not negative. So it says stay this. It just says don't move. What's 10 to the 0? 10 to the 0 is 1. So that's like saying 4 times 1. That means nothing. It means 4 times 1 is the same thing. So it says don't move the decimal. Keep it the same. Okay. Positive 7 means make it bigger by 7 jumps. So we're going to make it bigger and go to the right by 7 jumps. 1, 2, 3, 4, 5, 6, 7. Put some zeros in. And starting from the decimal, count groups of 3. So this is 32 space 500 space, like that. So that's 32,500,000. So now this, smaller. I have to make this number smaller. Oh, but there's no decimal point. So if there's no decimal point, always put the decimal point on the right. And it says make it smaller by 7 jumps. So 1, 2, 3, 4, 5, 6, 7, decimal. All the empty jumps, put a 0. Now to write it nice, I'm going to put it in groups of 3, starting at the decimal. Group of 3, group of 3. So 0.000 space 000 space 4. And you can put a 0 in the front or not. Highly welly, doesn't matter. Okay, I'll do one more with you. 4.28. Oops, 4.28. Negative 5. That means negative means make it smaller. So I'm going to go to the left and jump by 5. 1, 2, 3, 4, 5. Put some zeros. So let's write it nice. Cut it into groups of 3. So that's 0, 0, 0, 0, 4, 2, and 8. And I can put a 0 here if I want. Okay? So you finish up on your own. Okay. And it says, oh, I should have checked with my calculator. Let's check the last one. I forgot. 4.28 times 10. Can you see? Push this button, -5. Look, I can put it in my calculator, and it tells me the answer. But it doesn't put the spaces nice. We put the spaces nice.